Hi everyone, let's solve together some systems of equations with fractions. So the strategy that we're going to follow is by determining the lowest common denominator for each equation first, and then we're going to use that lowest common denominator to eliminate the denominators in each fraction, and then this will help us create two equations with no fractions, which we know how to solve. So in the first example, as you can see, we have x over 3, so we have a coefficient of 1 over 3 here. Y over 4, coefficient of 1 over 4, so that's a fraction. Number 2 is a whole number, but we're going to treat it as a fraction so that it can look like it's other terms in the equation. And the same thing applies to the next equation. So we're going to find the lowest common denominator of the first equation, which is, in our case, the lowest common multiple of 3, 4, and 1. So the lowest common denominator in the first one is going to be 12, which means that we're going to need to multiply by 12 every term in the first equation. Now, in the next equation, we have the coefficients 2 over 3, so denominator 3 and then denominator 2, and this has no denominator, so we can give it a denominator of 1, and the lowest common denominator in the next equation will be equal to 6, so we can multiply by 6 to get rid of every denominator. So this is how this is going to happen. So I'm going to rewrite the equation number 1, or I'm going to call them equations A and B because the numbers can be a little bit confusing when we are dealing with numbers in the equation itself. And here we go. I'm going to take the equation A and I'm going to write it the way it is. So x over 3 and then plus y over 4 equals 2 over 1. And I'm going to be a little bit strategic here. I'll leave a little bit of room between each terms because I'm going to bring number 12 right in front of each of them because number 12 is the lowest common denominator and we're multiplying by 12 every term. Now remember, if you're multiplying by 12, it means that you're multiplying basically like by 12 over 1. So you have multiplication of fractions. And when you multiply two fractions, you multiply numerators together, denominators together. Now, this will turn it into 12x over 3, right? Which will reduce to 4x. But I don't want you to go over this step because that just complicates and makes the solution a little bit long. I want you to think this way if possible. So number 12 and 3 will divide to give number 4. Number 12 and 4 will divide to give 3. And number 12 and 1 divide to give a 12. And this is how we, and I don't know, this term is a little bit harsh, but we're going to say this is how we would kill the denominators or eliminate this denominator. So instead of 12 now, we're going to have 4 times x. Instead of 12 over 1, y over 4, we're going to have, instead of 12 over 4, we have 3 times y. And down here, we're going to have 12 times 2, so that is 24. So you see, we created the equation with no fractions. Now, in the same way, we multiply 6 by 2x over 3, negative y over 2, and 0. And for this, I'm going to write the equation B the same way I did with equation A. So I'll write 2x over 3 minus y over 2 equals 0. And I'll multiply by 6 every term. Now, as you can see, we have 6 will divide 3 to give 2. 6 will divide 2 to give 3. And 6 times 0 is simply equal to 0. So 6 divided by 1 is 6 if we were to follow the exact same process the exact same way. So we're going to have number 2 multiplying 2x equals 4x. Now we're going to have number 3 multiplying y, 3y. And number 6 multiplying 0 will give 0. So this would be our equation B. And as you can see, with one simple step, we have created two very easy equations to work with. So we have 4x plus 3y is 24 and 4x minus 3y equals 0. We'll bring these equations right below each other. So I'm going to bring equation B right here underneath equation A, and I will examine each of them. Let's put the names on the side. And I'm going to check and see which variable do I want to eliminate. It seems that 3y and negative 3y, right, are easy to eliminate by addition. So we'll add the two equations. And that will bring us to 4x plus 4x. And then plus 3y plus negative 3y equals 24, and then plus 0. And you see that we have 8x. The 3y's will simplify and equals 24. So that will make x equal to 24 divided by 8, or 3. And next we have to solve the equation for y. I'm going to choose the equation B here. It looks a little bit easier than A. Again, it doesn't really matter which one we use. So 4 times 3 minus 3y equals 0. That means negative 3y is going to be equal to negative 12, and y equals negative 12 over negative 3, or y equals 4. So here we go. We have the solution, which is x equals 3 and y equals 4. Now, I encourage you to try to solve the next system of equations on your own. In the meantime, I will follow the solution right here by first examining the denominator. So we have 3, 6, and 2. So lowest common denominator, so the number that is divisible by all three of them will be 6, the smallest number. Now, for 5, 10, and 2, the smallest number, so the lowest number that is divisible by all denominators will be 10. So what that means is that we're multiplying here by 10 and we're multiplying here by 6. I'm going to follow a shortcut just to demonstrate the amount of work that you have to show on a test. So if you feel comfortable already to show the minimum number of steps, but still sufficient number of steps, this is how you would want to solve the system of equations. But if you feel more comfortable keeping your steps so you can see the process more clearly for yourself, just write the solution the way that makes more sense to you. So show those steps. So the way that I like to see it is this way. 6 will eliminate 3 here, and it will give number 2 multiplying 1, and 3 will simplify. Now 6 will simplify the 6 in here. 6 divided by 6 is 1, so 1 is multiplying 1, and then 6 divides into 2 to give 3, so 3 times 1. So the first equation will turn into 2 times 1 times x, 2x, negative 1 times y, negative y, and 3 times 1 is going to be equal to 3. So remember that these denominators have simplified, right? So 6 divided by 3, 2, 6 divided by 6, 1, and 6 divided by 2, 3. So the second equation, we have 10 divided by 5 equals 2. So 2 times x. Now 10 divided by 10 equals 1. So 1 times 3y equals 10 divides 2 to give 5. So 5 times 1. And as you can see, we have created two equations with no fractions very quickly. And now we're going to think how we're going to solve it. And you see that the coefficients of x have exact same value, and they are the same sign as well. So we are going to solve this system by elimination, and subtraction would work best in this case. So we're going to say that we have 2x minus 2x, and then we have minus y minus negative 3y equals, so equals positive 3 and then minus 5. So let's see what we have created here. 2x and negative 2x is 0x. We don't have to write this. So negative y minus negative 3y. So these two minuses will turn into plus, right? And we're going to have negative y plus 3y equals 3 minus 5 is negative 2. So we have 2y on the left equals negative 2, and that will make y equal to negative 2 over 2 or negative 1. Now, if y is negative 1, we're going to look for x. And I'm going to choose the first equation. Doesn't really matter. So I'll call this equation A and this one equation B. So we're going to pick equation A, and we'll put in the y for it, which is now known to be negative 1. So 2x minus the y value is negative 1. So don't forget that. All right. And that would be equal to 3. And we simply solve for x now. So 2x is 3 minus 1. And you can do this in a shorter way, obviously, because it's a simple subtraction. X is going to be equal to 2 divided by 2, or 1. So we got that the y value is negative 1, and the x value will have to be positive 1. And that will give us or provide us a solution for the system to be 1 and negative 1. And that's how we solve systems of equations that involve fractions. So next we're going to look at some bigger systems of equations. And for this, please follow me in the next video.